Can you hear me? Yes. Okay. 35-minute late. Okay. However, up to now, we discussed basic lessons, area, volume. Last week, we discussed questions and we discussed biomolecules. Api revision karna biomolecules, biomolecules, forces completely discuss forces and area, volume, theorem, and discuss trigonometry, final measurements, and what else? Yeah, today, from starting from today, I will explain about briefly and rapidly about heat lesson. After that, I hope to discuss. I hope to get a special day for thermochemistry. Finally, kinetic chemistry as well. At one day, one day, both lessons, and let's take 2 days, 2 or 3 days for heat lesson. Then the basic lessons completed. After that, after revise these lessons, I hope to get our revision times also discuss our chemistry lessons, and uh, this Wednesday we discussing normal lesson, statistic lesson. We can complete more than 60%. We can complete. Last week we discussed about you have to send the data set. I forgot to send. Okay, I'll send data set and you can practice group the development of group frequency distribution. Okay, now today is the date of today 15th of the half of March month completed. Finished now. You have another 15 days and uh, April, May, June, July, 4 months. 4 month mean 120 days. 120 days plus 15. අපි එතන 10ක් දාමු 130 days. Overall 130 days only to do everything. Only 130 days. Okay, the main thing, you should have a proper plan. You should have your own plan how to manage all 3 subjects within this 130 days. After this month, you have another 120 days. Very dangerous and very important time. Okay, let's start. Pause. Sorry, heat. Okay, do you remember what's the meaning of the heat? Yes, heat is an energy. Heat is an energy type. Heat is an energy type. Heat is an energy type which is formed due to temperature difference. Heat is energy type which is formed due to temperature difference. I told heat energy always transfers from high temperature to low temperature. That's a heat direction always. That's a heat direction always. Heat energy always transfer from high temperature to low temperature. High temperature to low temperature. This is the heat direction always. Heat lesson, we can classify it, we can categorize into 3 main subcategories. The entire heat lesson, that's a heat, that's the meaning of the heat. The heat is the energy which is formed due to temperature difference, and always heat energy transfer from high temperature to low temperature. Always heat energy transfer from high temperature to low temperature. Okay. Now heat energy, heat lesson, we can classify it into main 3 sections. Main 3 sections. The first one, thermal expansion. Thermal expansion. Okay, these expansion questions very important because last time I think 2025 exam don't have thermal expansion question as I remember. I don't know, still I don't have structured essay paper. Man දැකපු විදියට essay or MCQ part don't have expansion question. Therefore, this time 2026 most probably you will have expansion question. Okay, the second part is a thermal measurements. That means quantity of heat. Thermal measurements. Thermal measurements. The final part is the thermal transportation. Thermal transformation. Transformation. Thermal transformation. Okay, today our target to discuss thermal expansion in very short method, in very rapid method, and discuss thermal expansion question. I think morning or afternoon, daily refresh paper number 5. Okay, we have discussed 4 papers. These refresh papers very important. I have included lot of exam and exam related exam type questions in relevant area. Today lesson you have heat lesson related exam type questions and past exam questions. Okay, our first target of today complete the thermal expansion. Okay, what's the meaning of the thermal expansion? Thermal expansion, what's the meaning? Do you remember? Do you remember what's the meaning? The definition of thermal expansion. It's very simple part. What's the meaning of thermal expansion? Thermal expansion. When you increase the temperature of any object, what happens? The size of object or the volume of any object increase the volume of any object or the space taken in the surrounding increasing, we call as a thermal expansion. The space taken in the surrounding increasing with temperature, that we called as a thermal expansion. This thermal expansion mainly three types. What are the types? Do you remember? Thermal expansion mainly 3 types. What are the types? Thermal expansion mainly 3 types. What are the types? What are the types? Yes, good. Thermal expansion mainly 3 types. What are the types? What are the types? Solid expansion. According to matter type, we can classify thermal expansion into 3 types. Solid expansion, liquid expansion, and gas expansion. Solid expansion, liquid expansion, and gas expansion. Solid expansion, liquid expansion, and gas expansion. Okay, according to the matter type, we can classify thermal expansion into 3 main sections: solid expansion, liquid expansion, and gas expansion. Solid expansion, liquid expansion, and gas expansion. Okay, Now you can see all material types, all matter types are expanding. No, හැම material එකක්ම expand වෙනවා. That means all substance materials are mainly three types according to physical state. Solid, liquid, and gas are all materials. According to thermal expansion classification, all materials are expanding. Solid, liquid, and gas, all materials are expanding. Now we can say all materials are made up with what? Molecules, no? All materials are made up with molecules, no? All materials made up with molecules. If you got solid, they are highly compacted. Materials are highly compacted. Okay, in molecular level, I think you can remember I explained in molecular level how to expanding. With temperature, what happened with increase in the temperature, what happened, the molecule kinetic energy increasing. With increase in the molecule kinetic energy, what happened, molecule vibrations are increasing. With higher vibrations, what happened, the gap between molecules are increasing. That's why the spaces between molecules are increasing. That's the reason for increase the volume and increase the size and increase the surface space taken in the surrounding. Space taken in the surrounding. Okay, that's the story. If you got liquid, the same condition, the same point. In liquid made by molecules, but they are not highly compacted like solid. They are not highly compacted like solid, but they very close. Wait, I have issue. Give me a second. Okay, now okay. Okay, now okay. Is it clear? The board? Yes. Okay. Thermal expansion mainly three types according to matter type: solid expansion, liquid expansion, and gas expansion. Solid expansion mean solid materials. Solid materials highly compacted. Molecules are highly compacted. With temperature increase, their molecular kinetic energy increasing, then vibration increasing. Due to that, what happened? Due to that, their spaces increasing. Spaces increasing. That's why the space taken in the surrounding increasing. Liquid also same concept with vibration, temperature vibration increasing, then the distance and space between molecules increasing. That's why the volume increasing. Gas also same, but gas freely available. They are freely available with more spaces. With temperature, what happened? Their molecule kinetic energy increasing and their spaces increasing and the volume increasing. Okay, that's the actual expansion in molecular level. What happened in expansion? What's the meaning of contraction? Thermal contraction the opposite way. With temperature decrease, they start to compact due to less vibration. Less vibration, they compact. That's the meaning of contraction, the opposite way. Right. Now you know all materials, solid, liquid, and gas, all materials are expanding. All materials are expanding. Okay, let's go into solid expansion. Solid expansion. Solid expansion. Solid expansion. Solid expansion again three types. Solid expansion again three types. What are the three? Yes. Linear expansion. Linear expansion. Area expansion. Area expansion and volume expansion. Volume expansion. Okay, remember the classification. The thermal expansion according to material type, mainly three types: solid expansion, liquid expansion, and gas expansion. Solid expansion again three types: linear expansion, area expansion, and volume expansion. Hari? Linear expansion, area expansion, and volume expansion. Hari? Linear expansion. What's the meaning of linear expansion? First topic. Linear expansion. I'll rapidly explain. Okay, you can understand this. Linear expansion. What's the meaning of linear expansion? With temperature increase, the length of any one-dimensional object. One-dimensional object means like a rod like solid material. Rod ka length increasing. The delta L is actually the increasing length is the thermal linear expansion. The increasing length is the linear expansion. Linear expansion, the delta L. Delta L. Linear expansion. Okay. Okay, what is the meaning of linear expansion? With increase in the temperature, what happened? The length increasing. Only length, not area, only length. One dimensional rod type object. Length increasing. That we called as linear expansion. That we called as linear expansion. Linear expansion. Linear expansion. Linear expansion. Okay, now there are four main factors. The most important part. There are four main factors affect on the linear expansion. There are four main factors affect on the linear expansion. The first one, initial length. Initial length. Initial length. The initial length. The second one, temperature difference. sorry, three factors, no? Temperature difference, final one, material type, material or substance type, material type. Hurry. The initial length we called as L or L1. The temperature difference we called as delta theta. Delta mean difference, theta mean temperature, delta theta. Material type, don't need, I will explain later. Hurry. Now, if I got relationship, when increase initial length, what happened to the delta L? Thermal expansion, increasing. Initial length increasing, thermal expansion also increasing, delta L increasing. Therefore, that we called as the initial length and thermal expansion directly proportional. Initial length and delta L directly proportional to the L bar. When increase the temperature difference, delta L කොහොමත් වැඩි වෙනවා. Delta L increasing because highly temperature increase. That one also delta L directly proportional to delta theta as well. Delta theta as well. According to this relationship, first and second relationship, we can get equation, we can get expression or equation delta L directly proportional to L1 delta theta. Delta L directly proportional to L1 delta theta. Now to remove this proportional mark, I can use equal mark, equal delta L equal L1. To remove this proportional mark, we have to add constant alpha. This is a constant alpha delta theta. Delta L equal L1 alpha delta theta. This is the basic equation of linear expansion. Delta L equal L1 alpha delta theta. Now, what's the name of this alpha? Alpha is the linear expansion coefficient. Linear expansion coefficient. Linear expansion coefficient, remember. Linear expansion coefficient is the alpha. The alpha is the linear expansion coefficient. Linear expansion coefficient. I told there is another type, another factor, material type also affecting. The material type is the linear expansion coefficient is a constant that is depend on the material type. The linear expansion coefficient is the alpha is the constant depend on the material type. When change the material type, this alpha value changing. For copper, it has a specific value. For aluminium, it has a specific value. For rubber, it has a specific value. For plastic, it has a specific value. For wood, it has a specific value like this. Understood? Okay, that's the meaning of the linear expansion. Linear expansion. Linear expansion. Okay, that's all. Okay, again, if you need L2, L2 means final length, at the length of rod at final length, L2. Yeah, we can get relationship again. L2 equal, if you got L2, it is equal to L1. L1 is the initial length. L1 plus delta L. It is equal to L2, no? L2 equal L1 plus delta L. L1 plus initial length plus increasing length equal to the final length. Now L2 equal instead of this delta L venuata, I can substitute this part. No? It is equal to delta in L1 plus L1 alpha delta theta. Now L1 common to both, therefore I can get out this L1. L2 equal L1 1 plus alpha delta theta. Remember the equation of linear expansion. Final length, directly you can calculate final length. L2 equal L1 into 1 plus alpha delta theta. Delta L equation, the increasing length equation, L1 alpha delta theta. Okay. L1 alpha delta theta. Okay, within short time, I hope to discuss everything about expansion, and refresh paper we can discuss in Tuesday. No? We have time. You should have full knowledge about expansion before we move to expansion. That's why I'm explaining today. That's all about linear expansion. Now we are moving to what's the meaning of area expansion. Area expansion. Area expansion. What's the meaning of the area expansion? Area expansion means if you got this type plate, this type plate, this type plate. Now with temperature increasing, if it is increased, if it is increased in both dimensions, if it is increased in both dimensions, like this. Increasing like this in both dimensions, area, length and width both, like this. That we called as a area expansion. Area expansion. The initial area that we called as A1 and final area we called as A2. The increase area amount we called as delta A. The increase amount, area difference. This area difference is the area expansion, same as linear expansion. The amount of area increase due to temperature. Good? Good. Hari. For area expansion also, there are three main factors affecting. What are the factors? It is same as linear expansion. For area expansion also, you have three main factors. The first one, initial area. Initial area, I'm not going to write down now. Initial area, A1, now you already know. The second factor, temperature difference, delta theta. Temperature difference. The third one, material type or substance types. Material type. Material type. Hi. Maybe the same method. When you increase the initial area, what happened to the delta A? The amount of increasing area increasing. Therefore, that we called as a proportional relationship. This delta A proportional to the initial area. Delta A proportional to the initial area. And if you got temperature difference, delta theta increasing, what happened? The area increasing, the area expansion is increasing. Now that one also directly proportional. equal to delta theta. Now both directly proportional. Now you can get the relationship between that delta A directly proportional to A1 delta theta. A1 delta theta. Now to remove this proportional mark, delta A equal to A1. To remove this proportional mark, I have to use constant. It is beta, remember. Beta delta theta. Now what's the meaning of what's the name of the beta? What's the name of the beta? The name of beta, it is area expansion coefficient. That's the basic equation. That's the basic equation. That's the basic equation, and this name we call as area expansion coefficient. Area expansion coefficient. Area expansion coefficient. Remember, the area expansion coefficient is again a constant that is dependent on the material or substance type. Material to material, this area expansion coefficient will be changing. Material to material changing. Hari, patalesi, marlesi. Okay. Okay. Same as in linear expansion, again I can say this A2 equal to A1 plus increasing amount delta A. Now, yes, then A2 equal A1 plus this increasing amount is A1 beta delta theta. A1 beta delta theta. I can substitute A1 beta delta theta. A1 beta delta theta. A1 beta delta theta. A1 beta delta theta. Hi. Now A2 equal A1 common to both. Now A1 get into out 1 plus beta delta theta. Beta delta theta is the equation. 1 plus beta delta theta is the equation. Okay, that's the whole equation of area expansion, very easy. Okay, you don't need to write down, only for your revise. Okay, let's move into volume expansion as well. It's very easy. Another thing you want to know, always this area expansion beta is 2 times alpha. That one also you have to remember, beta always equal to 2 times alpha. If it is alpha 5, if you got copper, alpha value 5. Then beta value, the area expansion coefficient, it's 10. It's 2 times alpha. Right. Let's move into volume expansion. Same thing. What's the meaning of volume expansion? With temperature, the volume of three-dimensional object increasing in all dimensions. Volume expansion. Volume expansion. Volume expansion. Volume expansion means increasing the volume of any object with temperature. in all dimensions, 3D objects, in all dimensions, length, width, and height, all dimensions. Okay, the same object increase like this. Increase the volume. Now increasing in all dimensions. All dimensions. Okay, now this initial volume that we call as V1, the final volume we call as V2, and increase volume we call as delta V. Actually, this delta V is this delta V that means increasing volume with temperature, that we called as a volume expansion. That we call as volume expansion. Now, same as area and linear expansions, volume expansions also, there are three main factors affecting. The first one, initial volume V1. The second one, same as previous, temperature difference, delta theta. The third one, material type. Third one, material type. Same method, material type. Say as we discussed previously, for volume expansion also, initial volume increasing, delta V increasing, therefore it is directly proportional. Delta V directly proportional to initial volume V1. As well as delta V directly proportional to temperature difference, because when increase the temperature difference, delta V increase, directly proportional. Now we can get relationship delta V directly proportional to V1 delta theta. To remove this proportional mark, I have to add delta V equal V1 gamma delta theta. V1 gamma delta theta. That is a basic equation of volume expansion. Very simple. Okay, do we remember the name of gamma? It is volume expansion coefficient. Volume expansion coefficient. Volume expansion coefficient. Alpha linear expansion coefficient, beta area expansion coefficient, gamma alpha beta gamma, that is C, actually third letter, that is volume expansion coefficient. 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 Now, V1 delta theta and the volume expansion coefficient is a factor that is depend on the material type. Material to material, this volume expansion coefficient will be changing. And always this volume expansion coefficient gamma 3 times alpha. Think copper alpha value 5, copper linear expansion coefficient 5, then it is gamma value 15. It is 3 times, always 3 times than linear expansion coefficient. 3 alpha equal to any material 3 alpha equal to its gamma value. For volume expansion also same method we can follow to prepare V2 equation. V2 equal V1 plus delta V. Delta V. Now V2 equal V1 plus, instead of delta V, I can add V1 gamma delta theta. V1 gamma delta theta. Then V2 equal V1 get out 1 plus gamma delta theta. This is a V2 equation. V2 equal V1 into 1 plus gamma delta theta. Okay, that's a expansion, very simple lesson. That's expansion everything. Okay, now you can complete refresh paper number 5 completely. Okay, next week, next Tuesday, I will explain about quantity of heat complete part 10 to refresh paper number 5. And final week of this month, you have your third exam, next exam also will be held final week of this month. Okay, did you understood today lesson? Today, rapidly I explain about expansion. It's a very simple part. You only need to remember one equation and one relationship. Others all are same pattern. Any doubt? No. Then let's meet Thursday evening with refresh paper number 5 and quantity of heat part. Goodbye. Good night.